Okay, let's start off with anatomy of the respiratory system. So basically, this is your nasal cavity. This is your buccal cavity. Nasal cavity, otherwise known as the cavity found in nose. Buccal cavity is the cavity in your mouth. Then at the bottom here is your pharynx. This thingy here will go down to your esophagus. This one here is your larynx. So immediately below the pharynx, you have larynx and also esophagus. The larynx will contain the voice box. Okay, the voice box is found in the larynx. And then the larynx will go down and extend to form what we call the trachea. Trachea split into two smaller branches. We call it bronchus. Bronchus is singular. Bronchi. There are two bronchi, one bronchus. Bronchi is plural. Then subsequently, it is split into even smaller branches. We call them bronchioles. Okay, you can add an S if you are referring to two. And then at the end of the bronchus, we have what we call the assac, scientifically known as the alveolus. That is singular. Alveoli, plural. Okay, Ken?
Yeah.
So the alveolus will form the part of it that's your lungs over here, that's the lungs over here. Okay, and then it is surrounded by your rib cage made up of bones. In between the rib cage, you have muscles. We call them intercostal muscles. There are two types of intercostal muscles, the external intercostal muscle and the internal intercostal muscle. Okay? And then, you have the trachea, the thoracic cavity is basically surrounded. It's actually where the rib cage is. This whole thing is the thoracic cavity. And then here is the diaphragm. So you can think the thoracic cavity as the walls of the rib cage intercostal muscle and then the diaphragm. They will form a small chamber. We call it the thoracic cavity. Ken? Lauren?
Yeah.
So that's the anatomy of it. Next, let's take a look at how we breathe in and how we breathe out. When you breathe in, I want to show you an illustration. You can imagine two conditions. One condition is where the thoracic cavity is at its max. The next one, the thoracic cavity, is slightly at its minimum. This is maximum, this is minimum. Then this is, oops, should be the other way around, sorry. So you can imagine it as a small balloon with a hole that is leading towards your trachea, your nose, all this. A small balloon with a hole over there. When it becomes a bigger balloon, what happened? Small balloon, big balloon. You can imagine that when you try and open up the balloon, make it larger, it will suck air into the balloon, correct? Noreen, can you imagine that?
Yeah.
Okay. The other way around would be you have a big balloon, you make it into smaller balloon. Meaning, how to make it into smaller? You are forcing the air out, so it becomes smaller. So when you turn from here to here, you are actually breathing in. When you turn from here to here, you are actually breathing out. So how does this gonna help us? You can imagine this, instead of balloon, imagine it as your thoracic cavity. When your thoracic cavity's volume were to increase, the pressure will drop. And this allows the atmospheric pressure to become higher than the pressure inside the lungs. So air rushes in. On the other hand, if you make the thoracic cavity's volume to become lower, the pressure will increase. It will become higher than the atmospheric pressure. And this will allow the gas to rush out, hence breathing out. It is important here because I'm trying to get you to understand that what the muscles will do later to breathe in, they will do everything in its ability to increase the volume of the thoracic cavity. While this one, they will do everything that they can to reduce the volume of thoracic cavity. Okay, Ken, you follow me?
Yeah.
So how to increase the volume of the thoracic cavity? First, you can only control the thoracic cavity with your muscles, because muscles is the only thing that you can consciously contract and relax. And actually breathing is unconscious, but it is also a form of what we call, it is controlled by our brain subconsciously. So what we do is our external intercostal muscle, this is a short form. Our external intercostal muscle will contract. Our internal intercostal muscle will do the opposite. It will relax. These two will result in This two will result in your rib cage. Sorry, run out of ink. It will result in your rib cage moving upwards and outwards. At the same time, diaphragm is also a form of muscle. Okay? Diaphragm will contract. So when diaphragm contract, it will cause itself to flatten. You can imagine diaphragm as a muscle like this. When it is relaxing, it curves upwards or in an inverted U shape. When it contracts, it will become something like this. This is when it relaxes. When it contracts, it will become something like this. So, by doing that, it will effectively increase the volume of the thoracic cavity. Can?
Yeah.
So basically, when rib cage move upwards and outwards, plus the diaphragm being flattened, these two, this rib cage condition plus the diaphragm's condition would cause the volume of thoracic cavity to increase. When the thoracic cavity's volume increase, the pressure will decrease, and then the atmospheric pressure is higher than the thoracic cavity's pressure. So it will cause air to rush in to the lungs. Simple as that. How about breathing out? Breathing out is the other way around. The external intercostal muscle will relax. Internal intercostal muscle will contract. It will basically be the opposite. So then the rib cage moves downwards and inwards, while the diaphragm will relax. And this will cause it to curve upwards, or it will form a inverted U shape. When this occurs, this rib cage plus the condition of the diaphragm will then cause the volume of thoracic cavity to decrease, and then the pressure will drop. Sorry, pressure will increase higher than the atmospheric pressure. And this will cause air rush. pushes out of the lungs. Okay, simple as that. Can?
Okay.